Well, first of all, thank you, the committee of BISMAS 2020, for this opportunity. Let me introduce our team. My name is Hafid Suharyadi, and my co-author is Tugas S. Sugiarto. We are from Polytechnic Energy and Mineral Academy Gas under Ministry of Energy and Mineral Resources. Today, I will present an article entitled Corrosion Study of Graphene Coatings on Carbon Steels. This is the outline of our presentation. We are starting with the introduction that covers the motivation, objective, and method of our research. Then we go to the experimental method. Here we will see in brief the application of graphene epoxy on the plate carbon steels. After that, we go to the results and end with the summary. Well, this work is driven by a fact that the part of heat exchanger may suffer attacks from sulfur corrosion in oil and gas industry. This can lead to the degradation of the materials and heat transfers. Uh, this can lead to degradation of the materials and heat transfer surfaces. As a result, this leads to the reduced heating efficiency. Therefore, the corrosion resistance is a crucial thing in the material applications. The objective of this work is to investigate the effect of the graphene epoxy composite coatings on the plate carbon steel corrosion properties. This is conducted by varying graphene concentration in the graphene epoxy coatings. Okay, these are our materials. We use graphene and epoxy. Graphene is used because of their prominent properties such as good conductivity, good mechanical strength, lightweight, hydrophobic, resistant to temperature, and non-toxic. Epoxy is used due to their good corrosion resistance, thermal stability, and interfacial adhesion. We use bath method to produce homogeneous solutions of graphene and epoxy. After that, the homogeneous solution is applied using brush on the plate carbon steel. To evaluate the effectiveness of graphene epoxy coatings against corrosion, we use potentiodynamic polarization with Cortez potentiostat galvanostat instrument with a 3 electrodes cell system. Meanwhile, in order to do the elemental mapping, we use scanning electron microscopy with the acceleration voltage of 20 kilovolt and the magnification times of 250 times. Here are the results of the TEFL plots by varying graphene concentration in the graphene epoxy coatings. From TOEFL plots, we can observe the change in the corrosion potentials, corrosion current densities, corrosion rates, and corrosion inhibitions, as well as yeah, and the corrosion inhibition. We will see in details in the following page. This picture shows the dependency of corrosion potential on the graphene concentration. As we know, the corrosion potential indicates the corrosion susceptibility. Therefore, an and increase of the corrosion potential values strongly imply the inhibition ability of a multi-layer graphene coating on the corrosion attacks from the corrosive environment. The left in this page, we can see the left picture shows that the corrosion current densities of the uncoated sample is reduced by a factor of 30 to 36 with increasing the graphene concentration in the graphene epoxy coatings from 0 to 2, 5, and 10 weight percent. The picture on the right shows the similar effect compared to the corrosion current densities. The corrosion rate is reduced significantly by increasing the graphene concentration. So we can say that graphene epoxy coatings prevent the plate carbon steel effectively from the penetration of ions. The more graphene concentration, the more the corrosion protection resulted. Well, we also can observe the dependency of the inhibition efficiency on the graphene concentration. The inhibition efficiency is increased from 0 of the uncoated sample to 96.72% until 97.23% of the coated samples. This is a good indicator for our anti-corrosion coating. Well, from some measurements on the right picture, it shows that graphene, as depicted by carbon atoms, are distributed uniformly throughout the epoxy matrix. The green area is the coating area on the carbon steel substrate. So we can see that functionalization of graphene using bath method is running well. At the end, we can summarize that increasing the graphene concentration is a promising way to provide more effective barrier for plate carbon steels from acid attacks. This is indicated by an increase of corrosion potentials, reduce in the corrosion current densities, as well as the corrosion rates, and an increase of the inhibition efficiencies. From the same measurements, it is seen that effective functionalization of graphene produces uniform dispersion of carbon throughout the composite coatings. This enhances the corrosion resistance of plate carbon steels. Okay, thank you. This is the end of our presentation.